AMD is making some huge claims regarding RDNA 4. They're claiming a massive improvement to their machine learning capabilities, leading to a machine learning-based upscaler with FSR 4, which I can show you right here absolutely solves a lot of the fizzling and ghosting problems that we saw with FSR 3.1. It is a massive improvement in my testing. I will have a dedicated video published either before or after, or maybe even at the same time as this one, going really in-depth with a lot of side-by-sides, but I'll show you a little bit here. FSR 4 is way better than FSR 3.1, although it's not quite as performant. And we'll see that in today's video where we're benchmarking performance of the 9070 and 9070 XT up against NVIDIA's new 5070. I have the Founders Edition 5070 up against some kind of reference model version. I mean, there isn't really a reference model, but like not overclocked versions from AMD. We have the 9070 non-XT here from, this is the Nitro version from Acer, so Acer Nitro over here. And then the 9070 XT is Steel Legend coming in from ASRock. So those are the models, and I've left them at their out-of-the-box settings for the testing in this video. Now, their MSRPs are all very close. It's supposed to be $550 for the 9070 and the 5070, and then $599 for the 9070 XT. I'm hoping that that's true, but everything we've seen in the current GPU market is pointing to that not being the case. That being said, if I search Newegg right now for 5070s, there are some listed at $549.99 like they're supposed to be. The other prices aren't showing though. I'm hoping those aren't disastrous. I also wonder what supply is looking like. Searching for 9070 cards at Newegg, I'm not seeing anything before launch, so hopefully those are good and in good supply. But again, we've seen a lot of availability issues where if you're trying to buy like a 5070 Ti right now, it's nowhere near its $750 MSRP. So I'm hoping AMD comes in with good supply near its MSRP, but I do follow-up videos regarding current pricing, so we may need that if these cards don't actually land where they're supposed to. Speaking of GPU pricing, the one advantage, the kind of the silver lining to GPU prices being high right now is if you're going to fund your upgrade by selling your old GPU, which I highly recommend checking out Jawa.gg to do. This is the place that you buy, sell, and upgrade between gamers. They have some awesome deals. But again, you can sell your hardware here to fund your upgrade. Also, checking out the used market if there's not a lot of new GPUs in stock and honestly, just better deals. This is a good idea. Also, if you're looking for a pre-built system, you can use the PC Finder to find exactly what you are looking for. You can search by themes if you're going for a certain design. There's all sorts of cool stuff here, and if you find like the listing it yourself process a bit of a hassle, they'll even give you instant offers for your CPU or GPU. Take the hassle out of the process. You just let them know what you have. They give you an instant offer. If you accept it, they give you all the shipping info. Usually get paid within 1 or 2 business days of it being shipped. Tons of great user reviews. There's a big Discord community to get a lot of one-on-one feedback on your build, and also I can save you $10 off your first purchase using code OWEN10. Follow link in the video description and or pinned comment, and huge thank you to Jawa sponsoring today's video, which allows me to do a ridiculous number of benchmarks. So like, I tested a lot of stuff here, guys. We're gonna look at a ton of graphs to interpret all of what's going on here, because I tested everything. Ray tracing, not ray tracing, 1080p, 1440p, 4K, upscaling on, upscaling off, all of it. But let's get into the nitty-gritty details. One of the things is the fact that these don't have the same amount of VRAM. So we're gonna jump right into some ray tracing testing with Indiana Jones and the Great Circle. But at 4K Supreme settings, so not the full RT path tracing mode, but Supreme settings, and this game always uses RT, so why should you care about ray tracing? Well, some games at least make you use it. There's no way to turn it off, and I think that that might grow in the future. However, here we're seeing the 5070 running out of VRAM. It was unstable at these settings. The 9070 is 40% faster, the 9070 XT is 49% faster. Both the AMD cards, 60 FPS or better, with the 5070 only averaging 43. If you try to kick on DLSS to improve performance, it's still out of VRAM, and I got this really interesting glitch happening here on the left-hand side of the screen, where I can't really give you relative performance numbers. These 9070 and 9070 XT are doing well at around a mid 80 FPS range and 107-ish FPS range for the 9070 XT. But the 5070 is just out of VRAM. Everything's broken. I couldn't really do my benchmark pass. Now, granted, you could turn down textures, and if you're playing at a lower resolution, it also helps rein in VRAM. So if we look at 1440p Supreme settings, now we're seeing the 5070 giving us more of the performance that it's capable of at 97 FPS. That puts it 3% of the 9070 from AMD at 94 FPS, and the 9070 XT is in the lead here at 104 FPS. And again, these are 1440p results. However, I have found other areas of the game that are unstable with the VRAM 12 gigabytes at these settings. So anyway, on the 5070, so the VRAM capacity difference comes into play here with some ray tracing results. At 1080p resolution Supreme settings, the 5070 is able to hit 124 FPS, which puts it 8% ahead of the 9070, which is hitting 115. And the 9070 XT version is 12% ahead of its non-XT counterpart at 129. Overall, high frame rates in this game, despite it requiring ray tracing on all of the GPUs, and the AMD GPUs are putting up a good fight against NVIDIA. But there are definitely some games that don't use ray tracing, or you wouldn't use it. So I'll admit that Call of Duty Black Ops 6 tends to be more of an AMD favored title, but hey, we're looking at ray tracing. We'll also look at some of the games where AMD tends to perform well, and we're seeing that here. So here if we play at 4K basic settings, because I think in competitive games I prefer to test out low graphic settings rather than high, because I think a lot of times people will turn down settings to get higher frame rates and increase visibility, get rid of clutter, things like that. Here we're seeing the 5070 hitting 102 FPS. It's doing fine, but the 9070 is 33% faster at 136 FPS, and the 9070 XT is in the lead at 149, putting it 46% faster than the 5070. But honestly, if you're at 4K resolution, you would probably use upscaling, which gives us an interesting test here. This game supports FSR 4 natively within the game menu, and if we enable it at the performance mode and use the DLSS that's built into the game, which I'm pretty sure is a DLSS 3 version, on the 5070, we're getting the 5070 up to 181 FPS. Good experience. The 9070 offering 189, only leading by 4% now, and now the 9070 XT is only 12% ahead of the 5070, hitting 202 FPS. Image quality-wise, though, I think FSR4 is completely keeping up with DLSS 3, and that's huge. Notice if I switch back to to FSR3 instead of FSR4, notice that the AMD GPUs are more performant now. Now the 9070 is reaching 218 FPS, putting it 20% ahead of the 5070, and the 9070 XT is at 237, putting it 31% ahead of the 5070. So FSR3 is more performant than FSR4. However, it doesn't look as good. Again, I'll do a separate FSR video. You could also pause this, pinch and zoom if you like, all of that. But FSR3 here, if you look at the fine details, is not resolving as much detail as DLSS 3 was. But when I looked at these side-by-sides frame by frame, and FSR4 held its ground, but again, it reduced the performance advantage of the 9070 and 9070 XT. But again, they were still faster. And like I said, closed some of that image quality gap. If we drop down to 1440p resolution, basic settings, no upscaling, we see the 5070 doing a great job. It's hitting 176 FPS. However, the 9070 is 33% ahead at 234 FPS, and the 9070 XT offering 252 FPS, putting it 43% ahead of the 5070. Now, if we jump ahead, I've also tried using quality level upscaling, DLSS 3 versus FSR 4. Again, I've gone through frame by frame. FSR 4 is absolutely keeping up with DLSS 3 image quality in my analysis. But again, our performance leads have dropped. They're still there though. 9070 is 12% faster than the 5070, and the XT version is 19% faster than the 5070. So again, they have closed the gap on the upscaling quality, even if you look at the fine details in the distance, the little grading, the fine wires, things like that. I really think it's holding its own image quality-wise. Again, though, if we used FSR3 instead, it is a bit more performant. However, now if you look at the fine details on the leaves, the bricks, the shutters here, in all sorts of scenes, the FSR3 image is just blurrier and resolves less detail than the DLSS image does. Again, performance now is the 9070 17% faster than the 5070, and the XT version 23% faster than the 5070. If we go ahead and drop down to 1080p native resolution, basic settings, no upscaling, we see the 9070 leading by 20% over the 5070 at 294 FPS versus 244, and the 9070 XT is kind of running into system limitations here. I do have a 9800X 3D in the system, but at these settings, at this resolution, we're getting a bit CPU limited, so that XT version could only reach a 302 FPS average. Once faster gaming CPUs exist, perhaps it could show a little bit more headroom. Let's go ahead and jump into another ray tracing test, though. Spider-Man Miles Morales, 4K very high settings with RT reflections, native 4K resolution. The AMD GPUs are winning in this ray tracing test. The 9070 is winning by 8% at 53 versus 49, and then XT version is 20% ahead of the 5070 at 59 versus 49. And at 59, we're almost averaging 60 FPS ray tracing at native 4K resolution here. However, if we try performance mode upscaling, you'll notice that this is DLSS 3 versus FSR4. This game has a FSR4 implementation, whereas DLSS 3.7.1 is the latest version in the game. I would have to use DLSS Swapper if I was going to try out DLSS 4, so I chose to just go with what was built in the game. 5070 is now hitting 109 FPS, putting it 5% ahead of the 9070, but the 9070 XT version is actually in the lead here with 113 FPS. So, again, I have a more detailed image quality analysis here, but if you pause this, if you look at the tree branches in the distance and things like this, FSR4 is putting up a great fight against DLSS here. It's very, very usable, even in its performance mode. At 4K very high settings, no ray tracing, the 5070 is now hitting 89 FPS, no upscaling required, and the 9070 is hitting 100 FPS, putting it 12% ahead, and the XT version is hitting 110 FPS, putting it 24% ahead of the 5070. And again, that's native 4K very high settings, so really, you don't need upscaling in this game on this class of GPU if you're not using ray tracing. Of course, you could use it, but you don't need to. Dropping to 1440p resolution, let's kick RT reflections back on. And here we're seeing the 5070 hit 91 FPS. The 9070 hitting 97, putting it 7% ahead, and the XT version hitting 105 FPS, putting it 15% ahead of the 5070. Frame rates are so high here, I don't think we need to enable upscaling, although again, in my actual FSR4 image quality analysis, we will look at upscaling against the even at 1440p and 1080p resolutions. At 1440p very high settings with no ray tracing, the 5070 can hit 162 FPS. The 9070 is 11% faster at 180 FPS, and the XT version hits 195 FPS. So all of the GPUs can give you a high refresh rate experience here if you're not using ray tracing. At 1080p with ray traced reflections turned on, the 5070 is good for 128 FPS. The 9070 is 4% faster at 133, and the XT version hits 134 FPS. But if you look at the GPU utilization on the 5070, which I forgot to turn that setting on the monitors for my AMD GPUs here, sorry guys. But anyway, the point is we can see that there's some system limitation here, explaining why the XT version didn't stretch its legs a little bit further. At these settings, we're getting a little bit of system limitation. If we turn ray tracing off, though, that does ease some burden on the CPU as well as the GPU, allowing even the whole system to scale to much higher frame rates. Here we're seeing the 5070 hit 217, although again, it's showing like 94% utilization here, so we're probably a little bit system limited here as well. The 9070 is hitting 237, winning by 9% over the 5070, and the XT version is at 246, 13% ahead of the 5070. But what about heavier ray tracing workloads? Check this out, guys. 4K ray tracing ultra settings, DLSS and FSR3 performance mode. This game does not have FSR4 support, which is incredibly disappointing. That's my biggest disappointment with FSR4 so far, is just the game support list is nowhere near as big as DLSS 3, which can then be easily used DLSS swapper to jump to DLSS 4. Anyway, that being said, though, look at the performance, guys. 4K RT Ultra 9070 hitting 63 FPS, putting it 9% ahead of the 5070 at 58. However, image quality-wise, if you look at the fencing and things like that in the distance, DLSS 4 is looking massively better than FSR 3. So unfortunately, not even image quality. The 9070 XT is hitting 71 FPS, though, putting it 22% faster than the 5070. So for our ray tracing performance, this is really exciting for the AMD GPUs. What if we drop down to 1440p and turn off any upscaling? Here we're at 1440p Ray Tracing Ultra, which again is not the path tracing mode. This is the original highest RT settings before they added in path tracing. We'll look at path tracing in a minute. The 5070 and 9070 are tied at 45 FPS. So guys, the 9070 is as fast as a 5070 in 1440p RT Ultra in Cyberpunk. That's pretty exciting for an AMD ray tracing improvement generationally. The XT version is the fastest GPU here by 13%, hitting 51 FPS. The downside, though, is notice none of these are offering you a nice high refresh rate experience. So if you were going to use RT Ultra at 1440p, I think most people would end up using upscaling. And unfortunately, once again, we're locked out of FSR 4, at least for now, in Cyberpunk. And Cyberpunk has not been announced as one of the games that I could find that has announced upcoming support for FSR 4. So, kicking on quality level upscaling, but it's DLSS 4 versus FSR 3, so the DLSS is looking better. The 5070 is hitting 76 FPS, and the 9070 is 4% faster at 79. The 9070 XT is actually hitting 89 FPS, though, putting it 17% faster than the 5070. Again, downside being the image quality on FSR. Again, if you look at the fine details, things in the distance, we're just getting a little more blur, a little less stability on that FSR 3 image. Would have been really exciting to get FSR 4 into Cyberpunk, but unfortunately we don't have that. Now, moving down to 1080p. So if you're buying these GPUs for a 1080p display, check this out. We have RT Ultra hit native resolution. The GPUs can actually handle this pretty well. Although I'm going to use my fat head to fix a mistake here. I think this should be 79 that I typed in here, not 89. Anyway, so my forehead says 79. It is 11% faster, though. So the 9070 XT is hitting about a 79 FPS average, putting it 11% faster than the 9070, which in and of itself is only 1 FPS off from the 5070. So basically, we have moved to a point where the 9070 XT is faster than the 5070 at RT Ultra in Cyberpunk, and the 9070 is basically tied. If we kick on path tracing, though, AMD has not fully caught up. Also, though, keep in mind that for path tracing in Cyberpunk, this enables ray reconstruction as part of the DLSS settings for the NVIDIA GPU. AMD has talked about a neural denoiser in their announcement for RDNA 4, but at this point, I'm not aware of it being in any games, and it's definitely not in Cyberpunk. So that could be helping out the Cyberpunk performance here by replacing the other denoisers that are in the game. Also, FSR 3, again, giving us much worse image quality. But anyway, performance-wise, at 4K, none of the GPUs are really hitting usable numbers here, so I really don't think these 4K results for RT Overdrive matter much anyway. It's more just for the testing to see how they hold up. The 9070's in last place here at 32 FPS, the 5070 is 19% faster at 38, and the 9070 is in the middle at 35. There you go. Now, 1440p RT Overdrive. To get the 5070 anywhere near 60 FPS, I had to go down to DLSS balanced. Excuse me, which hits 58 FPS, and honestly, in the newer like Dogtown areas of the expansion pack and things like that, the 5070 is not really averaging 60 FPS here. Some people will find this good enough before kicking on frame gen to kind of save the day. Up to you where you're at with that. I would say that this is borderline usable, but I think a lot of people would be okay with it to get the path traced visuals on the 5070. It's 21% faster than the 9070, which is hitting 48 FPS. And the 9070 XT is kind of in the middle here at 54, 13% faster than the 9070, but not as fast as the 5070. It's fairly close though. But again, FSR 3 balanced mode, not looking anywhere near as good as DLSS 4. Yeah, that kind of factor that into your experience you would be having in this game. Now, let's go ahead and look at 1080p RT Overdrive with no upscaling. So this is our path tracing result with no upscaling clouding the differences. 9070 is hitting 34 FPS, and the 5070 is 21% faster at 41. The XT version of the 9070 is hitting 38 FPS, so once again, kind of in the middle there. It's 12% faster than the baseline model 9070. So none of them are really amazing at RT Overdrive, but if you were going to be trying to do path tracing on one of these GPUs, the 5070 is the best choice. However, again, it's not amazing for path tracing. Borderline usable at 1440p though. Now, let's go ahead and jump into some other testing. How about Silent Hill 2? This is Unreal Engine 5 showcase. Also in my previous testing, I've found this to be more of a NVIDIA-favored title in general. Here we're seeing the 5070 5% faster than the 9070 at 63 versus 60 FPS, 9070 XT hitting 65. So they're all pretty close here. And this is using DLSS 3 and FSR 3 in the performance mode. Because that was what was built into the game. I'm just using what's built into the game rather than trying to use DLSS swapper or anything like that. Silent Hill 2 4K epic settings, so no ray tracing and no upscaling. We're seeing none of the GPUs do very well, but the 5070 is 16% faster than the 9070 at 37 FPS versus 32. The 9070 XT is almost on par with the 5070, hitting 36 FPS, but I really don't think you'd be playing at these settings. If you kick on performance mode upscaling, again, DLSS 3 and FSR 3, the 5070 jumps to 76 FPS, putting it 6% faster than the 9070, but the 9070 XT is in the lead at 79, although I would give an image quality advantage to DLSS 3 versus FSR 3 if you look at the fine details. 1440p max settings, so epic with hardware ray tracing turned on. The 5070 is hitting 50 FPS, which puts it 2% ahead of the 9070, which is hitting 49. So they're basically tied. The XT version is furthest in the lead at 55 FPS, putting it 10% ahead of the 5070 and 12% ahead of the non-XT version. But if you kick on DLSS and FSR 3 quality, I will say DLSS again looks better than FSR 3 here. And the 5070 is hitting 75 FPS, putting it 6% ahead of the 9070. The 9070 XT is furthest ahead in FPS at 77, but again is not producing as good of an image because FSR 3 is what's built into the game. Silent Hill 2 at 1440p epic settings, no ray tracing and no upscaling. These GPUs are all good for around 60 FPS. The 9070 is hitting 60, the 5070 is 1 FPS ahead, and the 9070 XT is hitting 66, putting it 10% ahead of the 9070. Silent Hill 2 1080p epic with ray tracing. We see the 9070 at 68 FPS, the 5070 7% ahead at 73, and the 9070 XT at 76 FPS. If we go epic settings 1080p with no hardware RT, we see the 5070 at 89, putting it 5% ahead of the 9070 at 85, and the 9070 XT is furthest in the lead at 94 FPS. And let's go ahead and test out Ghost of Tsushima, which seems to be much better on the AMD GPUs. The 5070 at 4K very high settings with no upscaling. This is the max settings the game has to offer. The 9070 is 39% ahead of the 5070 at 68 versus 49. The XT version hitting 75 FPS. So this is definitely a game where you could just play at native 4K max settings on the AMD GPUs pretty comfortably, but on the 5070 you'd probably want to upscale. If we do upscale, we can see the 5070 hitting 81 FPS, the 9070 28% faster at 104, and the XT version hitting 110 FPS. However, this game does have FSR 3.1 support, but did not offer an FSR 4 override in the driver, which was a little bit disappointing. So it does seem like not every FSR 3.1 game can automatically have override to FSR 4 through the driver. I think it needs to get whitelisted by AMD before that support is offered. No word yet on if like you just DLL swap. I didn't actually try doing that manually. Now at 1440p very high settings, all the GPUs are doing well. The 5070 is hitting 87, but the 9070 is 34% faster at 117. And the XT version is at 126, putting it 45% ahead of the 5070. And I don't think we need upscaling at these types of frame rates. 1080p very high settings, we're seeing the 5070 hit 120 FPS. It's a great experience, but the 9070 is 28% ahead at 154, and the XT version is 38% ahead of the 5070 at 166. Let's jump into, oh no, I messed up. Okay, guys, we're gonna like, this does not say Ghost of Tsushima. This says God of War. You didn't see anything. Okay, this is 4K Ultra, and the 5070 is hitting 56 FPS, the 9070 is hitting 63, putting it 13% ahead, and the XT version is hitting 69, nice, which puts it 23% ahead of the 5070 as the baseline. Now, if we turn on DLSS 3, this game does have an FSR4 override, so I went ahead and used it. Again, I think image quality is very competitive with DLSS. And we're seeing 83 FPS versus 80, putting the 9070 4% ahead. If we go to FSR3 instead of FSR4, you can see the 9070 is now 9% ahead at 87 versus 80. So again, this is another example showing that the FSR3 performance is better than FSR4. But the image quality is better on FSR4. So I would probably use FSR4, but notice that that does cut into the lead that you get if you use FSR3 instead. Now, let's go ahead and jump to 1440p. Looks like I did correct the thing to say God of War Ragnarok now, by the way. Anyway, I'll get my fat head out of the way. 1440p ultra settings, the 5070 is now at 88, the 9070 is 11% ahead at 98, and the 20% lead for the XT version over the 5070. At 1080p ultra settings, we see the 5070 hitting 105 FPS, the 9070 15% ahead at 121 FPS, and the XT version 24% ahead of the 5070 at 130 FPS. By the way, my kids just got home while I'm recording from school. I think they brought a friend over. So if you hear giggling and noise and stomping above me, it's not in your house. Don't freak out. It's at my house, okay? Anyway, let's keep rolling with the benchmarks. So Final Fantasy 16 at 4K Ultra, none of the GPUs do very well at native, with the 5070 hitting 35 and showing some signs of running out of VRAM. The 9070 is 26% ahead at 44, and the XT version was in the lead. If we go to performance level upscaling, and again, I did not see an FSR4 override available for this game, we're looking at DLSS 3 versus FSR 3 at the performance mode. The 5070 jumps to 74 FPS, the 9070 is 16% ahead at 86, and the 9070 XT is 24% ahead of the 5070 at 92. At 1440p ultra settings, the 5070 does hold about 61 FPS, whereas the 9070 is 28% ahead at 78, and the XT version is at 84, putting it 38% ahead of the 5070. At 1080p ultra settings, we're seeing the 9070 25% ahead of the 5070 at 106 versus 85. So, you know, the 5070 was doing fine, but the AMD GPUs were faster. Moving into another Unreal Engine 5 game now, Hellblade 2: Senua's Saga, the high settings are the highest available in the game. I don't know how well you can see it, but look for weird aliasing on the 5070. The anti-aliasing doesn't seem to be working right unless you use DLSS on all my 50 series cards. Using the same driver, the 30 and 40 series cards aren't showing this issue. Anyway, performance-wise, 9070 is 24% ahead of the 5070 at 41 versus 33, and the XT version is 36% ahead of the 5070 at 45 versus 33. If we use upscaling to try to get more playable frame rates using quality, and again, I didn't see an FSR4 override in this game, so we're using what's built into the game, DLSS 3 and FSR 3. Quality settings, the 5070 is hitting 56, the 9070 is 21% ahead at 68, and the XT version is hitting 75, which is 34% ahead of the 5070. If we drop down to 1440p high settings, once again, if you look at like the tree branches and things on the 5070, there is weird shimmering and aliasing. Again, when we're using native TSR in this game, my 50 series are just having issues. Anyway, 5070 can hit 57 FPS despite those problems, and the 9070 is 25% ahead at 71, and the XT version is 37% ahead of the 5070 at 78. If we drop to 1080p high settings, we're seeing the 5070 do great at 80 FPS, despite the weird blurriness, not blurriness, but shimmering and aliasing that we're seeing. And the 9070 is hitting 99 FPS, 24% ahead, and the XT version 35% ahead of the 5070 at 108. If we could jump into Horizon Forbidden West, 4K native resolution, very high settings, we're seeing the 5070 hit 52 FPS, the 9070 35% ahead at 70, and the XT version hitting 76 FPS, putting it 46% ahead of the 5070. So the 5070 especially would want to probably use upscaling. The 9070 and XT could probably get away with just native 4K here. That being said, this game does feature an FSR4 override, so I went ahead and tried that out. So DLSS 3 versus FSR4 quality. The 9070 is 19% ahead of the 5070 at 89 FPS versus 75, and the XT version is hitting 96 FPS. Man, my kids are screaming loud. You can probably hear it in the background. They're having fun though, guys. It's fine. If you look at things like trees in the distance and all of that, I really think the FSR4 image quality holds up very well here. I'm not seeing any major worse quality on the FSR4 image compared to DLSS 3. So again, pretty exciting to see such a big upgrade to the upscaler from AMD. But if I do use FSR3 instead of FSR4, notice once again that performance is a bit higher. So if we use FSR3 versus DLSS 3, which is what's just natively available in the game, we're seeing 93 FPS versus 75, putting the 9070 24% ahead, and the 9070 XT 35% ahead of the 5070, hitting 101 frames per second. At 1440p very high settings, we're seeing the 9070 hitting 112 FPS, putting it 26% ahead of the 5070, which is hitting 89, and the 9070 XT hitting 121 FPS, putting it 36% ahead of the 5070. And if we drop to 1080p resolution, we're seeing all the GPUs are doing well. The 5070 is at 121 FPS, the 9070 is at 142, putting it 17% ahead. Then the XT version is at 150, giving it a 24% advantage over the 5070. And that's the benchmarks that I ran. That was over 50 different settings that we tested. So what is the overall summary? So let's break this down into some head-to-head charts where we look at each AMD GPU up against the NVIDIA counterpart. So this first chart is the 9070 XT version up against the 5070. Now again, MSRP-wise, that is a 10% price difference, making the 9070 10% more expensive. Keep in mind, though, that we have no idea if any of these GPUs are actually going to sell anywhere near their MSRP. And that's really important to keep in mind. So what we're going to look at here is the performance differentials, but it's difficult to discuss value until we know what these cards are actually going to be available for on the market. Anyway, what are these graphs even saying? The numbers here aren't frames per second, it's the percentage advantage for the 9070 XT versus the 5070, or if you see negative numbers like you see here, it's actually the percent of advantage of the 5070 against the 9070 XT in that direction. Notice that there's only a handful of places where the 5070 came out ahead, and almost all of them are path tracing. So the RT Overdrive mode is really the only place the 5070 is winning, other than a minor lead in Silent Hill 2 at 4K epic settings. So the 9070 XT is definitely faster than the 5070. The geo-mean of all of these results, and another way of looking at this is sorted from biggest lead to worst loss for the 9070 XT. The geo-mean of all of these results puts the 9070 XT 20% faster than the 5070. So that is a pretty meaningful advantage, and this includes a lot of ray tracing benchmarks, and that's important to note, right? This includes a lot of ray tracing benchmarks. Now, personally, I think that's completely fair because, first of all, the 5070 is powerful enough to use a lot of ray tracing results, maybe not the path tracing ones. But also, more games are using ray tracing, and some games we're seeing now require ray tracing. We've seen that in Avatar: Frontiers of Pandora, Star Wars Outlaws, Indiana Jones and the Great Circle, the upcoming Doom Dark Ages, RT only. So we are starting to see more games focusing on RT, and I think game developers like using ray tracing, and as we get in the next console generation, I think that will be important. That being said, for those of you who are like, look, I'm just going to turn off ray tracing to get better performance, man, and I don't care if a few games require it. Here is the no ray tracing results. If we completely filter out ray tracing, then the only win for the 5070 is by 3% in Silent Hill 2 at 4K epic settings, where it had a 3% lead, so it was really basically a tie. The GeoMean now puts the 9070 XT 27% faster than the 5070. Now, it's only fair to also look at what if you just throw out anything that isn't ray tracing? You're like, okay, what if we just isolate for ray tracing performance? Well, then we get this chart. So in this chart, we really need to be careful because there is a pretty massive outlier here in the advantage of the 9070 XT, where it had a 49% lead in Indiana Jones at 4K Supreme settings. Now, that's fair because it had enough VRAM and the 5070 didn't. But it's really more of a VRAM related result rather than an actual ray tracing hardware performance result. Although ray tracing tends to require more VRAM, so it is actually important to have enough VRAM for ray tracing. So anyway, just keep in mind that when we look at the GeoMean, which shows the 9070 XT 8% faster, that there's at least one outlier in its advantage, probably pulling that number a bit in the positive direction. Also, you should be aware that depending on which games you test, they use very different amounts of ray tracing and types of ray tracing. I'm really sorry for the stomping up above, guys. Anyway, I still teach full-time. I have a family. I film these videos when I have a chance. Tried to film before they got home from school, but anyway, guys, they're just kids having fun. Enjoy. Anyway, so the only actual losses in ray tracing, though, were ray tracing overdrive. So it's really only path tracing where the 5070 has advantage. So that's pretty interesting. That being said, again, the 9070 XT, if we're comparing MSRPs, is $50 more. But again, I have no idea what real world market pricing is going to be like. But this is a pretty exciting result because it used to always be the case that if you look at AMD versus NVIDIA generations, it's like AMD keeps up pretty well or even wins in rasterized performance, but as soon as you turn on ray tracing, they have a big disadvantage. So it has this huge caveat. If you're looking at the 9070 XT and the 5070 at around the same price, honestly, the 9070 XT in most ray tracing games that aren't path tracing is actually better at ray tracing than the 5070, and it has enough VRAM at 16 gigabytes where you're gonna have less trouble spilling over your VRAM buffer when you're using ray tracing. Pretty exciting there. Anyway, another thing that we could look at is what about no upscaling though? Because I'm using a lot of upscaling here, especially with ray tracing, and they don't really produce the same image quality. So if we want to drop to just, I see a lot of comments that are just like, I don't want to use upscaling, I don't want to use ray tracing, I just want to play native 1440p and I want a GPU that's strong enough to do it. So if that's the results that you want to look at, this is separating out for 1440p, native resolution, no upscaling, no ray tracing. In this case, I'm showing the 9070 XT 30% faster than the 5070. So that's interesting. Personally, I like to use upscaling, and if I have the performance for it, I'll often turn on ray tracing as well. So I'm not sure if this result represents how I would use the GPU, but the results are here for you to examine. Anyway, let's go ahead and switch over to what about the actual GPUs that have the same MSRP? Again, we don't know if MSRP is going to be a realistic thing here, but the 9070 versus the 5070. Once again, the negative direction on these results is how much faster the 5070 is compared to the 9070 if it has the lead. And the positive results on this side is what percent faster is the 9070 versus the 5070. Here, I'm getting the GeoMean of my entire test suite, so all resolutions, ray tracing on, ray tracing off, upscaling, FSR3, FSR4, all of it. I'm getting the 9070 as about 10% faster than the 5070. Priced the same, 10% faster. Again, though, this does include a lot of ray tracing results and even some path tracing results. So do keep that in mind. Again, another way of looking at the data set is sorted from best result for the 9070 to worst result for the 9070, best result for the 5070, and it looks like this. So you can definitely see that the 9070 wins more often than not, and the worst losses are coming in ray tracing overdrive mode. As long as we're not using RT Overdrive, it's usually less than a 10% advantage for the 5070 when it does have the lead, and again, that's usually in heavier ray tracing workloads. And also just Silent Hill 2 doesn't seem to be a good game for AMD GPUs. Now, again, we could sort for what if we only wanted to focus on ray tracing. So if we only focus on ray tracing, we're getting this. So the 9070 does get some wins, including, again, a massive outlier, 40% lead in Indiana Jones 4K Supreme because it had enough VRAM and the 5070 didn't. That's heavily contributing to the result here. Overall, we're seeing that the 9070 only comes out 3% slower in the geomean, but I think if you threw out that big outlier, it would fall a few percent further. I think it's more like a 5 or 6% loss, because you can see that it does get some wins here. So the 9070 is sometimes faster in ray tracing than the 5070, but it also sometimes loses, and the worst losses are in RT Overdrive, path tracing mode, and its biggest win is when the 12 gigabytes of VRAM just isn't enough for the 5070 to handle the ray tracing. Again, though, we could sort this out for what if we just remove all of the ray tracing results. So again, if you're like, I'm not going to play RT-only games and I don't care about ray tracing, I'm turning it off. If that's you, then we can see that the 5070 only gets a few small wins, and they're all in Silent Hill. The rest of the games are all advantage for AMD, and overall, I'm seeing a 17% faster result in the geomean. Now, this still includes upscaling and a lot of different resolutions and things like that. So the last chart we'll look at is, what if we just wanted to do 1440p, no upscaling, no ray tracing? So if you filter out everything else from my data set, you get this, and we can see that the only win for the 5070 is by 2% in Silent Hill 2 at 1440p epic settings, and the 9070 is on average 20% faster at 1440p when we're not using ray tracing. So we've seen tons of charts. Any final thoughts here? I mean, my final thought really is this graph for the 9070 XT up against the 5070. Again, MSRP does put it $50 more expensive, but look at this. There's almost no losses for the 9070 XT, and they're all in path tracing, at which point the 5070 was a little weak for it, if we're being honest. So with all of that in mind, I think that if on the real market, these GPUs are pretty similar in price, the 9070 XT is looking very good. But again, it might sell way above MSRP. The 5070 might sell way above MSRP. I just don't know for sure what's going to happen with that. But this certainly looks like the more exciting comparison. When we instead look at the 9070 versus the 5070, it's just a bit less exciting, especially since they're, it does get some more losses here. Now, again, one of my biggest caveats so far, because ray tracing, again, in the heaviest workloads, it's an NVIDIA advantage still. But on average, again, remember the 9070 XT still was on average ahead in my ray tracing suite here, which is pretty interesting. So really the biggest caveat for me in a gaming scenario is the upscaler. Not because AMD didn't close a lot of the gap with the upscaler. Again, I have showed the FSR4 side-by-sides, and I'll have a whole separate video on this. FSR4 is looking very good. It's just its game support list is still not anywhere near as big as DLSS 3, which can then easily swap to DLSS 4. So anyway, that's kind of my biggest caveat on all of this, if I was deciding which one to go with. But again, 9070 XT looking pretty good if you can find them at the same price. Now, if we did analyze 9070 XT versus the 5070, if they both have the same, actually hit their MSRPs, it does mean that the 9070 XT is 10% more expensive, or 9% more expensive, so I guess I could adjust this. And on average of all of my tests, including ray tracing and not ray tracing, just averaging it all together, it came out about 20% faster, which means, sorry, this should be 1.09, which means that it's only on average providing about 10% better value if you want to look at it from a value proposition. But again, that's heavily factoring in a lot of ray tracing results. If I focused on my 30% faster when we looked at just 1440p native, no ray tracing, no upscaling, Then it's offering about 19% better value. This is like performance per dollar. And then if we looked at it, again, I guess I'll do it this way, at just ray tracing, it's about 8% faster in my ray tracing testing for 9% more money, putting it about parity, 1% worse value. So interestingly here, no matter how you look at it, the 9070 XT at MSRP versus MSRP, compared to the 5070, does appear to be better value than the 5070. But again, the caveat on game support list for DLSS versus FSR4. And then there's also just if you're using professional workloads that benefit from CUDA, things like that. But again, the 9070 XT has 16 gigabytes of VRAM. I'm not gonna give any like hard and fast recommendations until I see what real world pricing looks like. So stay tuned to my channel for monthly GPU buying guide updates. And I hope all of you have an excellent day. Also, don't forget to check out Jawa.gg to sell your GPU and fund your upgrade. Again, I can get you $10 off your first purchase using code ON10, finding the link in the video description and/or pinned comment.